Hi everyone, this is a workshop on software development or software development workflow related to how to perform the full development, testing and deploy cycle. And we're going to use the FXGL project as a case study or as an example. So the workshop consists of two main parts. In the first part, we're going to look at a bit of theory in terms of how things work, what tools FXGL as a project uses to build, develop, test, and deploy. And then we're going to move on to the practical bit where we are going to take the latest copy of the code, add minor changes to the code, push it back to where the code lives, and we're going to thus complete the full cycle, including both theory and practice. This thing, if you've never used GitHub, I'll just briefly introduce what these things are. This is what we call a repository on GitHub. GitHub itself is like a server for code. It's like Dropbox, cloud storage for your code. And it has lots of interesting features that are very, very helpful during the development process. And you can see that there are multiple tabs. We're going to go through those ones that are important for development. And you can also see there are various always like widgets that are available over here and to the side. If you don't have a GitHub account yet, it's a good idea to create one after this session, because ultimately this is one of the prominent platforms for developing your project, for storing code. It's just much easier to then share your code with, say, potential employers if you're planning to get an internship, or if you're applying for a job. Having a GitHub account is not going to get you a job, but it will certainly strengthen your application, provided that you have some projects on GitHub. This is the watch list. This is a number of people who will be watching various changes to this repository. So if there's a new issue, for example, or if there's essentially any kind of change, meaningful change that gets applied to this repository, these people will be notified. This is a number of stars a repository has. It's like a bookmark, I suppose. People who have seen this project before could star this, and then they can, on their account, remember where this repository is. This is a number of forks that the repository has. You can create a fork, which is like a copy under your username, under your account, of this repository. And that allows you to either modify your code locally on your side, and then eventually push your changes back to peer, to the main repository. And it will come back as a pull request. That's something that we're going to look at after a moment. There are also various reasons you can use forks for. So you can create a fork to, say, just have a clone of this repository under your account for that moment in time. Maybe because you want to study it, go through the source code. And another potential use case is when you want to create a completely different project, take it in a different direction, but still use the same base code of this repository. These are like tags for the repository. You can use them to identify what the project does. You can also see the releases page. If you click on that, it will tell you, cool, it will tell you how many releases there are, what the latest one is, which is this one here. And this one is in draft because this will be released very soon. And then you can potentially also get the library in a packaged form for this specific version. There is the sponsor button if people from the community would like to sponsor this project. This is how many the people who have projects which directly depend on this project. This is usually determined by the various dependency management tools that they use in order to get access to this project. And we'll talk about dependency management towards the end. And these are the contributors to this repository. These are various people in GitHub who've created their own copy, which is fork, and then they've modified some code. Then they pushed that code back to this one, and that bit of code got merged with the project's repository. And then we can see the languages that make up this repository's code base. It's specifically for this project, it's 50% Java and almost 50% Kotlin. And then you have the README, which is going to show usually what this project is about, like a description. And then you can find out how to use the project, a minimal example, and so on. But README is going to differ significantly from one project to another. So I'm not going to focus on that too much. And I'll just very briefly mention what the project actually is, although this isn't particularly relevant to the workshop itself. This is a game engine. You can build 2D games, you can build some experimental 3D stuff. It's written in Java/Kotlin, so any kind of JVM language should be able to use this project. And essentially it can do what a game engine can do, more or less. Now let's look at how this project is structured, and then we'll look at these tabs, which are quite important. So this is the top level directory, and you can see that these are like folders, pretty much like on your hard drive. You can browse through them. For example, if you click on that, you're going to see all the files in that directory. These are Java modules, actually. And they also happen to be Maven modules. So Maven is a build tool. And there's another alternative, which is Gradle. So if you've never used Maven or Gradle before, they are dependency management tools or build tools. They allow you to unify how your project is structured and also how your project is compiled, built, and developed. And this is significant for one reason, because it makes it super easy for other developers to get your code and build it without really worrying what your project is about or how to do anything with your project. So that's the great thing. They can just take this project without knowing anything about what the project does or how it works. They can just type one command, which is in this case Maven package, and the entire project gets built. And you don't need, as a maintainer, to say, for example, how to build your project, where to put files or anything like that. So it unifies the build quite significantly. And that's great, because you no longer need to kind of drag sources around to see how to compile it or anything like that. The Maven build tool uses these files called pom.xml. So if we'll look at this one, which is the top level one, It lists all the modules that this project has, and it lists other information that may be of use for developers, but particularly it also lists dependencies, plugins that are used by this project. So another great use of dependency management / build tool is that it will automatically manage the dependencies for you. So you don't need to manually download any of the libraries that this project uses. These dependencies are universal for all of the modules in this project. And here there are various plugins that are used that specify how, in particular, how to build all of the modules in this project. And as with dependencies, you can override these configurations. It's probably quite a lot to take in at first. So the good news is it doesn't have to be that complex. If you have one module and if you're using, if you're building a simple project, the POM XML file is actually quite small for that. Yes, you typically create this file for any of the projects that you're going to use. However, IDEs can generate this file for you. So if we find a module that is quite simple, for example, this one. This is just about 80 lines, and you can even get rid of that. So for a simple project that has only one module, all of this will go. It's literally about 15-20 lines, of which about 15 lines are going to be generated by your IDE, such as IntelliJ. So all you do is just specify what dependencies your project has. And if it doesn't have any dependencies, then your XML file is going to be even shorter. And this XML file is specific to Maven. The Gradle tool uses something different. It's a build.gradle file, which is configured in a slightly different way. It has its own syntax. But in terms of functionality, it's more or less the same. Right, so that's the build tool that is currently used by this project. And this build tool doesn't only say how to build the project, but also how to test it, how to deploy it, how to generate, for example, documentation for your project, maybe even a website. So if you're planning to use Java, then you should know at least one of the two, either Maven or Gradle. Then you can kind of figure out what the other one does, but at least one is preferable. So this is the sort of main tab. This is the code tab, and it contains the source code. You can browse through it. That's what the tab is for. Now we have the Issues tab, and here we can see lots of things that either need to be done, need to be fixed, need to be answered. This is like your to-do list, but slightly more flexible. So this could be one of your users who have discovered a bug, for example. Then they can go to this Issues tab, and then they can create a new issue by clicking on this button. And then they can say, well, your latest version of this project that I'm using doesn't do X, although in the previous version it did. So there must be some kind of a problem there, or a bug of sorts. So can you have a look at that, please, kind of request. We also have feature requests. So your users may create an issue to say, I want this feature because my use case is this. So this would be the place to create a new feature as well, or to open an issue to create a new feature. And these features / to-do things each has a bunch of labels attached to them. So you can see this one, for example, has difficulty easy, good first issue, and help wanted. And also the language is Java only. And we'll get to those when we talk about pull requests, because tagging issues is quite important for newcomers to your project. And I should note that this is fully tracked in terms of an issue list. So it's very easy to go back in time and see how the discussion developed. You can see that there are 729 closed issues. So if we click on that, we can find all of the issues that were closed. And we can just go through each one of them. So you can see that there is a discussion almost around how something could be implemented, how something needs to be fixed, and so on. And this is really useful. Right, quite an important bit, this one, pull requests. So a pull request, which is PR for short, is what you create once you've created your copy, made some changes in that copy, and then you want now the changes to be integrated to the main repository, back to the original maintainer. That's when you create a pull request, which is, let's just see one of the example ones. For example, that one. So you can see in this pull request what the change actually is. And then these changes can be also seen in the files changed subtab. So you can literally down to every single line of code, you can see what has been changed. Because maintainers will then have a job to review this. And then provided everything is correct, then these changes could be merged back to the main repository, thus completing the entire cycle of they took a copy, modified it, and then returned the copy back with some new changes. And that is known as contribution. So when you modify your own copy and then contribute it back, you're effectively contributing to an open source public repository. It's kind of a big deal, not that much of a big deal, but it is quite important if you're planning to boost your CV, for example. Again, it's not one of those things that will definitely get you a job, but it will definitely strengthen your application when compared to other applicants, for example. Particularly if they've never contributed anything, or if never worked on any open source project before. So this is something to consider, not necessarily in your first year, but definitely when you're somewhere in between second and third year, maybe mostly when you're in second year, because as soon as you get to third year, you're going to be quite busy. I'm kind of talking about the higher education in the UK, generally speaking. So if you're in a different university in a different country, then years might work differently for you. But in this specific case, since we're in the UK, the third year is quite busy because you have your final year project to focus on. So I would say second year is a really good point in time to start just looking into various options and how you might contribute to other people's projects. And you get to not only contribute, but also learn a lot from the entire process from other developers as well, who are going to review your code and hopefully get it merged. Something to note, I suppose, with pull requests, you don't want to start with a contribution to a large project with multiple maintainers, because then you'll have to be very careful with their guidelines, with the philosophy almost of the project, of the repository, because they have their own guidelines, which they will talk about in the contributing README file. So in the top level, typically, there will be a file called contributing.md. If you look at that, you will find a bunch of, it's like guidance, how to proceed with contributions, because you don't want to just dive into the code. You first want to find an issue in the issue list over here. And then you want to find something that you're familiar with, something that you can potentially fix. And also look out for things like good first issue and help wanted, because these are usually, they have a higher chance of being accepted as PRs, because the maintainers themselves are saying, well, we don't have time to work on this issue, so it would be good if somebody from the community could contribute this. And they're not necessarily hard to fix issues, because typically on open source projects, you don't have a lot of maintainers, so the number of leading developers for that project is usually, well, quite a small number. So they won't have time to work on every single issue, even on easy ones, or I would say particularly on easy ones, because if maintainers work specifically on the easy issues, then they won't have time to tackle the hard ones. And if they can't solve the hard problems, then nobody can, because maintainers know best about their project. And for that reason, you might actually find, for example, this one, I think that will take about 2 lines of code to fix, but it's still time. So that needs to be cloned, that needs to be in the right file. You'll need to add those 2 lines of code, you need to commit them, you need to push them, and we'll go through that process in the practical part of this workshop. So it all takes quite a bit of time, and if you multiply that by number of issues that we have, then that is not feasible to complete all easy issues by the maintainers. So look out for them and see if you can contribute. That would be a good start. I'm going to close these ones. Okay, so we've talked about that. We've looked at pull requests, and I suppose one of the things to mention is the branches and the whole branching system. So with GitHub, you have multiple branches if you want to. You typically start with the main branch, and then you can add more. Branches are like copies of the same code base, but with slight modifications. Suppose you want to start with this branch, which is currently called dev, and you don't really want to work in that branch because the code is currently working, so you don't want to kind of mess it up. And you can start by creating a new branch, work in that branch, see that your new code is working, and then once you're happy, you can then merge that new branch with the old one. There are 2 branches, as you can see. One is dev for development, and the other one is release. All the code, all the new code goes into the development branch, and it stays there until everyone's happy that it can get merged with the release branch. The only purpose of the release branch is to maintain a specific point in time in terms of code. So you'd place your sort of production level, as you would call it, code into this release branch, and it will stay there until the next version. And it just allows you to maintain this, again, cycle of development. You make sure the code works, you keep it in the release branch, and then you start experimenting with your new code, and then you put it back into the release branch once you're done. Okay, let's have a look at actions. Actions is, I suppose, workflows, is the built-in CI for GitHub. CI stands for continuous integration. And in that continuous integration, well, in simple terms, it's a build server. It takes your code, it builds it, it may test it, and it may even deploy it. And if something goes wrong, it will send you an email or somehow notify you saying something broke. So you kind of need to fix that kind of thing. And specifically here, we can see three workflows. One is called cross-platform CI. Let's start with this one. And we can also look at the workflow file, which is defined in YML. It's located in the code tab, and it's under .github workflows, and then the file name YML. And this is the entire workflow file. It tells us, or it tells the build server to set up JDK 15 on a virtual machine that runs Ubuntu, and essentially test the project. So this is the reference testing workflow, and each workflow has its own purpose. So they're not just all doing the same thing. This workflow specifically, once the test completes, will generate a test report. And we're going to look at testing in the practical bit. This test report then goes into here. This is another platform called CodeCov. This is where all of FXGL's testing results are stored. It will tell you on a per module basis what files are covered and by what amount. So testing is, it's kind of a weird thing. You're writing code which is going to test your other code that you wrote a while ago. But there are some advantages, however. If, for example, you want to test that a formula given a specific number returns a specific result, then that would be something to test in your tests. And tests also help you write the API for your code, because then you can really start thinking about your classes in those modules, what they do, and what kind of functionality they're supposed to have. For example, if we were to take this module, let's go into the Java branch, maths, and let's open this file. So on a per file basis, CodeCov, once it's processed your test results, it will tell you which lines of code are being covered by your tests. So the green ones are good. They're good in the sense they're being tested. We don't actually know if they're correct. So there is a distinction there between being tested and being correct. you can't really know for sure if they're correct. They're only passing the test that you've written. So if the test is wrong, then obviously the code might also be wrong. The yellow ones are partially covered. They typically include things like branches. That means one side of the if statement worked, as in it got tested, and the other side of the if statement did not get called, which is why it's yellow. If we can find any red ones, no red ones in this file. Let's pick a different one. So there's a red line, there's a red line. Red lines are those that were never called in your tests. So we don't actually know their behavior because they are not tested. And that easily tells us which lines we can start testing in the process to improve code coverage. Code coverage is the percentage of how much of your code base is being covered by tests. Currently, FXGL is at 64%. So if we check how many lines of code we have in the FXGL's repository, I think it was about 65,000-ish. And then we can say that out of that number, about 64% of those lines of code is being covered by tests. Kotlin, Java, yeah, about 63,000 lines of code of sort of meaningful code. These are just configuration files. So there's quite a lot that is not being tested. That's the takeaway message there. And it would be good to have some more tests in the future. So that was one workflow. Let's get to the other ones. This is what Java CI with Maven does. It takes the code, it builds it, it tests it, and then sends the test results to the CodeCov platform. The other one is called deploy dev snapshot. Snapshot is typically used to mean this is a development version, which is why it is commonly used by, say, developers to test that new feature that has been just added works as it should, or if a bug that they wanted to fix got fixed and they don't want to wait until the next version, so they can pick up this development version. Which gets built on every push to the branch. So when we, in a few moments, add new code, this thing is going to kick in and start building it. Once it completes building and testing, and note that it uses Java 11, the other one used Java 15. This one is the base level, so our minimum version for FXGL is Java 11. After the testing has completed, it will deploy this to Sonatype, which is another platform. This platform takes, it's like a gate, it's like a security check. It takes all of your packages, such as jar files, and then it will check them for using a specific format. So you need to have javadoc jar, you need to have sources jar, and so on. So they can then be published for real. And once the checks go through, because this one has snapshot attached to it, it will deploy it to a snapshot repository. It's like a temporary repository because we don't want to publish it in a real repository because it's a development version. And when the snapshot thing goes away, for example, when we release the next version, this whole thing is going to end up here. This is the Maven Central or Maven Central repository. that's where all projects that are fully released will go to. And this is where your Maven build tool can then download dependencies from. So we've almost completed one aspect of this cycle. We publish a project in here in this Maven Central, and then when somebody uses the Maven build tool to get a dependency, for example on FXGL, then they're going to grab it from here. And this process is automatic, so you don't need to do anything else. Which is why build tools are a great idea. They simplify the entire build process. And then we have the last workflow, which actually contains 3 different jobs inside. So if we look at the workflow file, we will see that it has 3 different operating systems. And the reason for that is this workflow is going to run in a cross-platform way, because we want to know if our code works exactly the same on all these 3 platforms. We're also using a different version of Java. You can see that there is an EA attached to it, to the version. EA stands for early release or early access. And that's there for us to see if we are going to end up with problems in the future. Because the current version is 15 and it works fine. But what if in the next Java version, something is going to break? So we kind of want to know ahead and possibly even talk to the developers of OpenJDK and then say, well, this thing got broken. I don't know where the error comes from. Can we have a discussion around that type of thing? So it's reasonably important. Chances are it won't break, but there are some things of note here, which is why early access versions are important. And then you can see that certain actions pass, certain fail, and then when they fail, they email you saying, well, it's a whole process that is automated, which is great. And then you can kind of check what failed. And these actions also run, apart from the deploy one, when somebody wants to contribute their code into this repository. So it goes through the pull request process, which will automatically trigger these workflows. So it's really great for developers because you don't need to worry about these things and do them manually. On that note, I think this completes the overview of how the processes work, or at least in theory. And now we're going to get to the practical stage where we're going to just add a few lines of code and then see all these processes in real life, as it were. I think somewhere here there was a method that wasn't tested. So this is something that we could test, because I don't want to be modifying production code. Production code is anything that lives under source main. There is also test code, which lives under source test. And that's where we're going to add, yeah, that one is a simple one. Let's do this one. So we can see that indexOf is a method in the class called array, and it returns -1 when there is no such value, when we're looking for a specific value. So let's go and do that. This is IntelliJ. I'm not going to go over IntelliJ. You've probably used it before. It's quite a common tool to use for anything Java related. And if you do Control-Shift-T, you'll end up with the test file, which is where the test code lives. And all of this test code is testing this file. So we need to find index of this one over here, which tests that index of by equality method, which in turn calls index of. So we should be able to call that with a value that doesn't exist in the array and therefore trigger the -1. So assert that array index of by equality, I'll just type H. This element is not inside this array, so this should return -1 is -1. And then we can also run this test to make sure that it passes. And the testing facility is provided by JUnit 5 to be more precise. And you can see that anything green is great. So that means this test passed. From the command line, we're going to use the git tool to first, well, you can type git diff to see what you changed. It will tell you that we've added this new line. We're then going to say, well, add it to the draft so we can commit it in the future. And you can see it's now green. It says that it's in the staging area. It's like draft mode. And now if you don't have any more things to add, you can say commit with a specific message. The message is going to say added missing test case, and then we're going to push. Now this change has just gone to the GitHub server, and you can see that the latest commit now says added missing test case. If you check that latest commit, it will also tell you on the website what you changed. And this is a great way to keep track of what you've done over any period of time. So if you wanted to revert something, or if you accidentally, if you've accidentally broken something, then that would be a good way to start figuring out which thing broke. And you can see this little icon which says that something is building. If we go to the actions and these workflows, you can see that they all already started working, processing all our changes. So whenever we modify some code in that repository, all workflows are going to kick in and start doing their job, which is great because they're automated. The developer themselves, they don't need to worry about anything that can be completed automatically. These typically run about 5 minutes, you can see from these ones. Hopefully these won't fail. If we get a green check mark, that means everything is fine. Given that we only changed one line and we introduced a single assertion, it should be fine. And then once this specific workflow, which is deploy dev snapshot, when this thing completes, as we looked before, it's going to send it over here. This is going to push it to the snapshot repository. And all developers who are currently relying on that snapshot version will be able to get the latest version immediately. Well, provided they update, start their ID, in which case the ID might start downloading the latest snapshot if they have such an option turned on. And that is pretty much it. That is the entire process for how to do stuff, not necessarily just with FXGL, but with also other projects. Each project is going to be different. The processes are generally the same. You develop code, you send it off to GitHub, it either builds it itself or sends it to somewhere else like Travis, which is also another continuous integration service. And then eventually, if you need it deployed, it will deploy it for you. And by the way, you can see that this workflow is finished and everything passed. So we're happy with the change. Okay, I'm going to stop recording now. Thanks for watching.